Alrighty, this one's about density and the mole. So we're going to solve a few mole questions that involve density, which kind of adds a layer of complexity or adds kind of an extra potential step and conversion into our conventional mole problems that we're doing. Because we can always relate mass to moles, and now we can say we can also relate mass to volume. So density, equals mass over volume. All right, you've certainly looked at density before, likely at this stage if you're watching this video, and it can have units of any of the following. Really, it can have grams per milliliter, or it can have grams per liter, or it can have grams per cubic centimeter. Generally speaking, although it's not ubiquitous to say, these two are used for liquids, and these two here are used for liquids, and this one is generally used for solids, but that's not always true. You can use cubic centimeter just synonymous with milliliter. Remember, 1 milliliter is equal by definition to 1 cubic centimeter, so doesn't much matter which unit you use. But basically, we can integrate these into molar problems, as I was saying, because the mole we know is linked to mass through molar mass, and maybe it helps to make your mole diagram again. Okay, but what can we do from the mole? Well, we can go from mole to mass through molar mass, and vice versa. We can go from mole to the volume of a gas through the Avogadro's law, 22.4 liters per mole at STP. And we can go from a mole to the number of particles. That would be like molecules or atoms. We can do that by using Avogadro's constant, 6.02 times 10 to the 23 of anything in a mole. Okay, so on top of this type of a situation, we now have the added bit of being able to use density to relate mass to volume. Mass to, it could be volume of a gas, or it could be volume of a liquid as well. So we'll have a look at a few exemplar problems, kind of increasing complexity as we go along here. So what is the density of SO2 gas at STP? Okay, and in solving these problems, take the same approach you usually would. Start with the end in mind. We're looking for the density. So density will have units of either grams per liter or grams per milliliter. Let's go with this one for now. And what we need to begin with is anything we know or anything we're given. So what are we given if we know the compound? Well, at least if we know the compound, we are given the molar mass of that compound thanks to the periodic table. And if you look up on the periodic table, 1 sulfur and 2 oxygens, you're going to find out that it's 64.1 grams per mole. Okay, so we're going to have 61.4 grams per mole. And what we see is we need grams up top, which we have, but we don't have liters as a denominator yet. We need to get that in the denominator, and we need to cancel moles. So obviously we're going to use, if it wasn't a big enough tell that it tells you it's at STP, I guess it could be a red herring, it could be a trick, but in 1 mole we have 22.4 liters. We're going to use the Avogadro's law there, okay? And if you look at the units now and do your unit analysis, moles cancel out. We end up with grams per liter. And if we do the calculation, 64.1 divided by 22.4, we get 2.86 grams per liter as the density of SO2 at that given temperature and pressure. Here's another one. Another one says a 7.50 liter flask contains 14.73 grams of a gas at STP. So if you just, stop everything for a second, they're basically giving us a volume and a mass. So they're kind of giving us the density of that gas, right? Then it says, what's the molar mass of the gas? So beginning with the end in mind, as we usually do, we want to solve for molar mass. Molar mass has the units grams per mole, okay? So we need to get this thing in grams per mole, all right? We need grams in the numerator, we need moles in the denominator. Well, we could start with the density given, 14.73 grams per 7.50 liters. All right, that gives us our grams up top. And then it just asks us to somehow cancel out that volume, unit liters. So you can see it's at STP, meaning we can use the whole 22.4 liters in a mole situation. Okay, and that'll be our conversion. What that does is it will cancel out the unit of liters and leave us with our proper target units, grams per mole. Right, and so we just do the math on that. 14.73 times 22.4 divided by 7.50. And you're going to get 44.0 grams per mole as your molar mass. And if you're wondering, like, hey, is this a real gas? If the question has been designed carefully, it should be a real gas. And actually, it turns out this is CO2. Not that I expect you to really know that, but that's something I happen to know. Bling bling, this one's about a gold chain. Gold's density is 19.3 grams per cubic centimeter. Okay, so this is more the standard we would use for a solid. A gold chain has a volume of 13.6 milliliters. How many atoms of gold are in the necklace? So it's a little bit cheeky and weird what I've done here, but I've given the volume in milliliters. Remember, that's just the same. 13.6 milliliters is really just saying 13.6 cubic centimeters. So you can go ahead and sub in that unit if it makes a lot more sense, which you can imagine it likely does. Okay, so we again should start with the end in mind, and what we're looking for is how many atoms of gold. So we want our final unit to be atoms of gold. Okay, atoms of AU. So how are we going to get there? Well, anytime we're counting particles, right, we expect this number to be very large. All right, and that's because we're going to have to use the factor of 6.02 times 10 to the 23 atoms in 1 mole of gold. Okay, so in a mole of gold, there's going to be 6.02 times 10 to the 23. We are inevitably going to have to use this conversion factor. Okay, it's just like, where do we go? How do we get there? So we're probably going to start with the density. Let's get the density out there. 19.3 grams per cubic centimeter. We know we also have a volume of 13, so we're going to multiply that by 13.6 cubic centimeters. That's going to take care of the cubic centimeters for us. Okay, and now all we have to do is get rid of that grams on top and get rid of that moles on the bottom. See? So it would make a lot of sense to say mole up there, grams up there. What's that value? Well, that's the inverse of the molar mass of gold. So let's look up the molar mass of gold. It is 197 grams in a mole of gold. And so that's going to be the conversion factor to use there. And let's check the units and make sure we got this thing right. So yeah, cubic centimeter canceling, grams canceling, moles canceling, and it's going to leave us with atoms of gold. So processing this, let's just take a second to look at this. What you would do on your calculator, I think, which is the most foolproof way to not make a mistake, rather than trying to like pump in so many of the, of the big 10 to the power of numbers and all this kind of stuff, it might jam you up. Do this part. Do 19.3 times 13.6 times 6.02 divided by 197. So taking care of all that. And then whatever answer you get, just multiply that by 10 to the 23. Okay, that's what I would do to kind of reduce the margin of error. And then put the answer in proper scientific notation. And if you do that, you're going to get 8.02 times 10 to the 23 atoms of gold. I love gold. Alrighty, we got one more here to do. Probably the toughest of the bunch, so I think you can handle it though. Let's have a good look at it. So carbon disulfide, CS2, is a liquid. And it has, of course we know it's a liquid because there it is. It has a density of 1.26 grams per milliliter. What's the volume of 4.50 times 10 to the 22 molecules of carbon disulfide. Okay, so again, let's begin with the end in mind. We're being asked what's the volume. So our target unit is likely milliliters, could be liters as well, but we see the density in milliliters, so maybe we aim at milliliters for this one. Okay, and then so we just have to think, how do we get there? Well, we need milliliters on top. All right, so I'm not going to start by writing down, we have this density, but if I use it straight up, it puts milliliters on the bottom, so I'm not quite sure that's right. So instead, let's start with this. We have 4.50 times 10 to the 22 molecules. Okay, so what can we do with that? Well, we know that we can go from the number of molecules to moles, right? We can go with particles to moles. And so let's do that. Let's transform this to moles by saying in every 1 mole there's 6.0 times 10 to the 23 molecules. Okay, that's going to get rid of, it's going to challenge me to write the word molecules and leave enough space is what it's going to do. There we go. It's going to get rid of the term molecules. So, ba-boom. So now we've got the thing converted to moles. All right, so now that we're in moles, what we can do here, okay, is, let's see, we also know the nature of the compound. We have molar mass at our disposal, which is grams per mole. So we can get rid of the mole on top by using the molar mass of this thing. So let's try that. If you look up on the periodic table, 1 carbon and 2 sulfurs, you'll get that it's 76.2 grams per mole. Okay, and so we can throw that factor in, and if we do that correctly, then we're going to get rid of moles as well, and we've now got grams on top. Aha, now it makes sense, because if we multiply this whole thing, so again our target unit is milliliters, if we multiply this whole thing by the upside down density, so we take 1 milliliter divided by 1.26 grams, now we're going to get that mass factor canceling out. We're going to get grams canceling, and we're going to end up with milliliters. So to do that whole thing, again, what I would coach you to do is multiply 4.5 times 60, whatever that is, 76.2, okay, divided by 6.02, times 1.26. Okay, do that part, and then multiply that by, what do you got? You got 10 to the 22 on the top, and you got 10 to the 23 on the bottom. So according to your exponent laws, that's now going to turn out to be 10 to the minus 1. Okay, so you're going to multiply it by this, 10 to the minus 1. Right, and then if you do all that, you should end up seeing it's 4.52 milliliters volume. Okay, tough one, but work on these. There's lots of practice out there that combines particles, mass, volume, and density together in mole questions, and they can be tricky, but if you can master those, boy, you got the world by the tail.